Okay, here's a question that's either extremely profound or extremely weird. Probably both. Have you peed on every second of the day? No, I don't mean in one go. I just mean, do you think that across your entire life you have peed during every single second of the 24-hour clock? Amazingly, I'm not the first genius to pose this question.
Do you think you've peed every minute of the day? Like every minute in the 24 hours we have every day?
But I am the fool that's going to try and answer it, because it's not really a biological question, but a statistical one. Specifically, it's a version of the coupon collector problem. And the answer is a bit more complicated than you might imagine. The coupon collector problem asks, if you're collecting coupons at random from a big set, how many draws do you need before you've seen every coupon at least once? Imagine a cereal company's giving away collectible coupons in their boxes, say 100 different designs. Every time you buy a box, you get a new random coupon. How many boxes would you have to buy before you'd collected them all? Early on, it's easy, you're collecting new coupons all the time, but by the time you've got, say, 95 of them, the odds of getting a new one are increasingly small. You're drowning in duplicates. So you don't need to buy 100 boxes of cereal. You don't even need to buy a few more than 100 boxes of cereal. You need to buy a lot more, which is great news for the cereal company and bad news for your wallet and for your sanity. So how many do you need to collect to get them all? Let's build it up intuitively. First, let's look at the expected number of draws to get all 100 coupons. The first one's easy. You've got none yet, so any coupon is new. You'll get your first unique coupon on your first try. But once you've already got one, on your second draw there's a 1 in 100 chance that you'll get that one again, and a 99 in 100 chance that you'll get a new one. Expected value works by calculating 1 divided by the probability of success. So the expected number of draws is 100 over 99, which comes out as a little over 1, i.e. you're very likely to get it on your second try. Now you have 2. The chance of getting something new is 98 in 100, so the expected number of draws is 100 divided by 98, which comes out as a little more over 1. As you go on collecting new coupons, the probability of finding a new one goes down, and so the number of draws you have to make goes up. To calculate it, you end up with an equation that looks like this. And because of that fun little logarithm that goes whoop, the way the maths works out, to get 100 unique coupons, you'd need to buy more than 500 boxes of cereal. And I'm not even sure my toddler could eat that much. But let's get back to the original question, peeing on time itself. The coupon collector problem translates neatly into our problem of peeing throughout the day. We just replace coupons with seconds of the day and collecting with urinating. There are 86,400 seconds in a day. That's your coupon pool. Every second is a collectible item, except it's not a cute cereal animal, it's a moment in time in which you might have been midstream. Most healthy people pee for about 20 seconds at a time, so each time you go, you cover a 20-second window. That means every trip to the John is like reaching into a big bucket and randomly pulling out 20 coupons. The question is, how many 20-second pee windows do you need before you've covered every second in the day at least once? And how long would that take you? Because like the optimistic coupon collector, the more you pee, the more likely you are to be hitting seconds you've already hit before. You start chasing the rare ones, the midnight and 14 seconds, the elusive 4:37 a.m. So just like before, we plug our seconds to cover into the coupon collector equation and get approximately 1,074,816 seconds of urination. Divide that by 20 seconds per pee and you'd need approximately 53,741 pee sessions to cover every second. It sounds like a lot. It is a lot, but luckily we pee a lot as well. A healthy person pees about 8 times a day, so they'd be able to accomplish this lofty goal by the time they were about 18 and a half. That's the expected time to cover every second of the day with pee. Nice. Except expected values are kind of like averages. They're the mean number of tries you'd need to get every coupon or pee on every second. But what if you wanted to be sure you'd caught them all? For that, you need confidence. Instead of asking how many draws until I can expect to have everything, we instead ask how many draws until I can be X% sure that I've got everything. So essentially we're saying, I want to be 99% confident that I've peed on every second of the day. How long will that take me? You pick the confidence level you want. If you want 95% certainty, then there's a 5% chance that you've missed something. If you want 99% certainty, then there's a 1% chance of missing something, and so on. But as you approach hitting every second, the odds of getting a new one get smaller and smaller, so the higher the confidence level you want, the more pees it's going to take. In effect, you're trading time for certainty. To calculate it, we use this fun equation. And running the numbers like before, we can be 95% certain that we've hit every second after nearly 22 years. We can be 99% sure of covering them all after about 25 years, and 99.9% sure of peeing on every second after 28.5 years. So all of this means that statistically, if you're under 20, then there's still a 50% chance that you haven't peed on every second yet. If you're in your 20s, then you probably still haven't touched all of time. But if you're over 30, then congratulations. You have reached total temporal saturation via urination. You've peed on time itself. And yes, this probably is the most mathematically complex way anyone has ever talked about peeing. But wait, this has been statistics in full chaos mode. We've assumed that you've been urinating completely randomly across the full 24-hour clock, like some human sprinkler system with no circadian rhythm. Now, when you're a baby, that might be the case, and I've certainly fallen victim to that once or twice. But for the rest of us, it's just simply not true. Humans don't pee at random. We pee during the day when we're awake. During the nighttime, not so much, unless you're pregnant, old, or tragically overhydrated. So let's adjust the numbers to split the day into, say, 16 waking peeing hours and 8 sleeping non-peeing hours. If you never wake in the night to pee, then you're never going to hit 24-hour coverage. It's as simple as that. You're stuck in a loop of hitting the same waking seconds over and over again. But let's assume a little bit of pee does come out at night, hopefully when you've woken up and gone to the bathroom, but it doesn't really matter. If you pee 7 times during the day and 1 time at night, covering 20 seconds each time, then we've now got 2 coupon collector problems covering each part of the day. To cover every waking second will only take about 9 years on average, but to cover every nighttime second with just 1 20-second pee per night, that'll take you nearly 30 years. And that's just the average. If you want to be 99.9% sure that you've hit every second during the night, even that elusive 3:47 a.m, then it'll take until you're 45 years old. Of course, real life isn't even this tidy, so let's take a moment to account for all the messy human stuff that messes up the maths. For a start, not everybody pees for the same amount of time. We've used 20 seconds as a healthy average, but in reality, pee duration varies wildly, from quick 5-second trickles to minute-long power washes. So depending on how hydrated you are, how long you've waited, and whether or not you're going for a Guinness World Record, your time coverage per pee varies. It varies between people, and it varies between each person's pee session. And all of that affects how efficiently you're painting your 86,400 second canvas with your golden brush. The quicker you are, the harder you're making it for yourself, since you're essentially grabbing fewer time coupons every time you go. Then there's the fact that people don't pee at random times, even during the day. You might pee more in the morning or right before bed. Maybe you've just had a baby and you're peeing 15 times a day. Maybe you're a camel. The point is, there's a lot of overlap. If you're always peeing in the morning, then you're probably hitting the same 20-second window over and over again. That's like collecting the same stupid coupon 500 times. So we get clustering. That means that even during the day, some seconds get peed on a lot, whilst others go untouched for years. And once you add in this clustering, the time to reach temporal saturation creeps up even more. And let's not forget sleep. As we've seen, just 1 nightly pee makes a huge difference to temporal reach. In this case, nighttime peeing isn't an inconvenience, it's your ticket to bladder-based immortality. But just how much nighttime peeing happens depends a lot on your age and lifestyle. Kids and teens can sleep 9 hours a night or more with 0 nighttime pees. That's a third of the day totally uncovered. Whereas older adults and pregnant people often experience nocturia, which is a fancy way of saying that they wake up regularly during the night to pee. It's bad news for your sleep schedule, but great news for your nighttime pee coverage. And if you're a new parent waking up what feels like every 20 minutes to feed a crying baby, or a shift worker who's constantly flipping their day-night schedules, then you're absolutely smashing the nighttime pee sweepstakes. You're basically a 24-hour sprinkler system, and random statistics loves you. So to go back to our original question, have I peed on every second? The answer is, it depends. Every person's pee map is different, but statistically, if you're under 25 and sleep through the night, not a chance. If you're 30 plus and pee like clockwork, then you've got a good chance. And if you're a new parent waking up every 2 hours to pee and feed a baby, then you are absolutely smashing it. So the next time someone accuses you of wasting time on the loo, you can simply tell them, actually, I'm engaging in a long-term stochastic coverage project of the 24-hour clock. Or you can simply say, I'm trying to pee on time itself. If you enjoyed this totally excessive answer to a completely unnecessary question, then hit subscribe. I like to ask these sorts of questions all the time, just not always from the loo. This is Something Incredible. I'm Leila, and somewhere, something incredible is waiting to be peed on.